Module 5 discusses common locations for storage and dispensing of ethanol-blended fuels and will provide a basic understanding of these storage and dispensing sites.
Module 5, we're going to deal with storage and dispensing locations. The responder needs to be able to describe 3 common types of storage tanks at tank farm facilities, to be able to list potential benefits and challenges associated with fixed fire suppression systems at fuel storage facilities, and be prepared to list all of the agencies that may be called upon for support during an event at a fuel storage or dispensing location.
Often, when the response community thinks of storing and dispensing ethanol-blended fuels, we fail to think of the retail fueling station on the corner. As a result, we can believe that if there is no bulk storage operation or production operation in our jurisdiction, we have little to worry about. This could not be further from the truth. Today, nearly all gasoline in the United States is blended with some level of ethanol. Ethanol and ethanol-blended fuels are found at production facilities, bulk tank farms, rail transload facilities, construction sites, and retail fueling stations within your community and throughout the country. It is important for local fire departments to be familiar with the facilities in their locations. Any large volume of denatured fuel ethanol will typically be stored in conventional carbon steel storage tanks, such as those that are suitable for gasoline and other flammable fuels. Denatured fuel ethanol can also be stored in stainless steel storage tanks. These tanks are less common. Yet as consumption increases, larger ethanol tanks will become increasingly prevalent. These storage tanks should be identified by markings corresponding with the fuel stored. There are 3 general types of storage tanks at tank farm facilities: cone roof, closed top tanks, external floating roof, EFR tanks, which have an open top with a floating pan, and internal floating roof, IFR tanks. See Figure 5.1 in the participant guide, with a closed top and an internal floating pan. The majority of existing EFR tanks have been converted to IFR in recent years. Denatured fuel ethanol will typically be stored in one of these IFR tanks.
The most common storage is the internal floating roof tank. This is going to be a closed roof tank with an internal floating pan. They become evident by the eyebrows that are found up towards the top of the tank, and they will typically have some type of fire protection.
Spill containment dikes are required to contain the volume of the largest tank plus rainfall within the contained area. Additional fluid from a firefighting operation could lead to overfilling or breaching of the dike. As a side note, large horizontal tanks that are elevated do not fall under the same regulatory requirements for containment. These are much more common at smaller distribution facilities and in agricultural settings.
Some storage tanks have fixed or built-in fire protection systems. Fixed systems are a combination of components including foam concentrate storage, proportioning valves, and delivery devices that are permanently installed to provide fire suppression protection. These same fixed systems can service multiple storage tanks, manifolds, and loading and unloading racks. The system can be activated manually or by detection devices. Topside application of foam systems may require much higher application rates for ethanol-blended fuels than for previously stored fuels. Subsurface injection systems may not work at all with an ethanol-blended fuel. Fire department personnel should be working closely with terminal operators to keep abreast of changes in fuel storage at liquid product terminals. It is important to ensure the fire protection systems are meeting current industry standards and codes. It is also important that responders know how to activate the fire protection systems at a liquid product terminal. This is a slide showing you a pre-piped foam system in a large-scale storage tank. This shows you the device that will mix and aerate the foam from inside the tank. The foam deflector device is attached to most Type 2 fixed foam chamber discharge outlets. The deflector directs foam down and over a large area of the inside of the tank wall and onto the top of the burning liquid inside of the tank. Before the fire or foam attack can begin on a tank, responders need to calculate the available space within the tank, working with facility operators to calculate the available space in gallons will allow responders to know if the product needs to be removed from the tank before operations can begin, or allow the product to burn off to reduce product in the tank. Fire operations have to account for finished foam going into the tank so as to not overflow contents. Expansion needs to be taken into consideration. This would be the ratio of volume of foam formed to the volume of solution used to generate the foam. For example, an 8 expansion means 800 gallons of foam from 100 gallons of solution. Keep in mind, foam drain time will continue throughout the operation. Pre-planning for potential events at liquid product terminals is extremely important. Fire department personnel should develop good working relationship with the terminal operators and be very familiar with their operations. A significant piece of this pre-planning must include consideration for mutual aid partners. Fire departments that help provide protection to liquid product terminals should have access to high-flow firefighting foam equipment and access to large supplies of compatible alcohol-resistant AFFF foam. In some areas, this has been done by establishing caches of AFFF and equipment through consortiums organized between multiple terminal operations and the fire department. Fire department personnel should also be aware they may not be able to contend with a terminal fire operation and may need to contact outside resources for ultimate control of an emergency. Fire departments are encouraged to establish healthy working relations with these groups and with the storage facilities in their response area prior to an emergency arising. Fixed fire systems are currently the best protection for bulk storage tanks. Fire department personnel should be extremely familiar with these systems and pre-calculate their required flow rates. They should also pre-plan operations supplying these systems. Practice exercises should be scheduled at least annually to make sure responders are familiar with the pre-established plans.
Keep in mind that there are many different challenges involved in firefighting operations at a liquid product terminal. There may be limited access in both the terminal itself and in the tank design for firefighting equipment. At times, some locations may have inadequate water supplies to fight any type of significant fire. Personnel may have to contend with containment dikes and their systems, along with miles of exposed product piping. Liquid product terminals may also have loading racks subject to fire emergencies. Liquid product terminal operations can be very complicated, and responding to a fire emergency can be very dangerous to personnel. It is also not unusual for terminals that were originally built in remote areas to now be surrounded by commercial and residential growth.
Again, pre-planning is extremely important, and pre-established working relations between the fire department and the facility operators cannot be overemphasized. Smaller bulk distribution storage facilities may pose a unique challenge to the local fire department. These facilities are located throughout communities to better distribute fuel to the end user. Storage tanks in these facilities can be of a multitude of styles and layouts depending upon the age and location. Storage tanks may be vertical, horizontal, or a combination of both. Normally, the flammable liquid fuels, including gasoline and the ethanol blended fuels, are stored in these facilities in modest quantities. Most of these facilities do not have built-in fire protection systems. These facilities are normally designed with limited fuel spillage containment structure or areas and are typically unstaffed. Large bulk storage facilities also pose unique challenges to local fire departments. Storage tanks in these facilities have high capacity and high throughput. A variety of different storage tanks may be present: vertical, horizontal, above ground, below ground, or a combination of all of these. Flammable liquids, including gasoline and the ethanol blended fuels, are stored at these facilities in significant quantities. These facilities have detailed emergency response plans due to the sheer volume of the stored material on site. Pre-established working relations between the fire department and the facility operators is extremely important. Pre-planning cannot be overemphasized.
Both denatured and undenatured, or neat ethanol, can be stored at a production facility. The most common is denature-fueled ethanol, E95, E98. Ethanol blended fuels found at retail fuel stations are not generally found at a production facility. There will be denaturant stored at a production facility, such as natural gasoline or unleaded gasoline. Denaturants are added to ethanol through inline blending systems prior to the final product storage tanks. A typical example is shown in this photo. In this tank configuration, ethanol would be stored in the tanks identified as number 1 and number 2. The denaturant would be stored in the tank identified as number 3.
Transloading sites. A transloading site is where they are transloading the commodity from one mode of transportation to another mode of transportation. So in this slide, what they're doing is they're removing the product from the rail cars and putting it into over-the-road tank trucks for the final trip to the storage facility. Responders need to be aware of what kind of fire protection is available at these types of facilities and what they have for spill control. The final destination of our ethanol blended fuel is going to be the retail dispensing station. There are over 153,000 retail stations throughout the United States. Each one of these stations will have a combination of below ground or above ground tanks. Responders need to pre-plan these fueling stations. You need to be aware of if they're keeping their product above ground or below ground and the different commodities that might exist, including different levels of ethanol blended fuels. Depending upon geography, throughput, volume, fire code, and many other variables impact whether an above ground or below ground storage tank is used. Above ground storage tanks can be either vertical or horizontal in design. Nearly all underground storage tanks are horizontal. Inventory is brought to the retail station by highway cargo tanks. At retail sites, the most common tank configuration is horizontal underground tanks. The maximum pressure under which any underground tank is capable of holding its contents is 0.5 pounds per square inch. Tank capacities range from a few thousand gallons up to 20,000 gallons. These tanks are typically constructed of steel or double-walled fiberglass. Emergency shutoff valves will vary for each container due to the design and construction differences. Loading and unloading points will vary due to design and construction. Risers for multiple tanks will be color-coded or marked to identify the product.
Denatured fuel ethanol, E95, E98, is most commonly stored in storage tanks made of carbon steel. Denatured fuel ethanol can also be stored in stainless steel storage tanks. These tanks are less common. Pre-planning for potential events at liquid product terminals is extremely important. Fire department personnel should develop good working relationships with the terminal operators and should be very familiar with their operations. Liquid product terminals will likely be equipped with fixed fire suppression systems. It is important to remember that these systems could be rendered inoperable at the onset of an incident. From the liquid product terminals, the ethanol blended fuel arrives at local retail fueling stations. These stations will use underground storage and above-ground storage tanks. Although the amount of fuel stored at each retail fueling station is small, especially when compared to liquid product terminals, the sheer number of retail fueling stations requires that each possible emergency be pre-planned.